So here's another problem of this type, finding the function values of an angle. This time we're given something a little bit different. We're given that the terminal side of theta is on the y-axis. The terminal side of theta is on the y-axis. So what's that so far? Here's the initial side, and the terminal side of theta is on the y-axis, which means there are one of two possibilities. One possibility is there's the terminal side of theta on the y-axis, or the other possibility is this is the terminal side of theta. So here, the angle in question is clearly 90 degrees. 90. Here, the initial side, terminal side, in this case, the value of theta is 270 degrees. And so all we're given so far is the terminal side of theta is on the y-axis. So the question is, which of those is it? Well, that's why you must also be given an additional piece of information. We're given that the y value in question must be less than 0. You could just as easily have been given y value is greater than 0. One of the two must be given. It's random as to which one you happen to get. Or, more to the point, if you're working a problem in the future, in Calc 3 you're working a problem, or 2-3 years from now at university you're working some problem in an engineering course, this would come from somewhere else in the problem. For our purposes, it is simply given that the y value must be less than 0, which means this is not the right picture, because if this is the point, then that y value is positive. This is not what we want. We've been given the y value must be less than 0. So we know, for one thing, we know this is a 270 degree angle, and we're on some point on this piece of the y-axis. All right? So we know this is the picture. And so I'm going to draw this again. There's the initial side, there's the terminal side, and this is my value theta. Now, we were not asked to find it, but coincidentally, because this is, remember the word is quadrantal, remember the word quadrantal. A quadrantal angle is one where the terminal side lies on one of the axes. In this case, because of the given information, we can deduce that theta must be 270 degrees. So now, we need a point that lies on the axis. The question is, which point do we pick? And our argument from the previous video says, it doesn't matter. Because of similarity, it doesn't matter which point we choose. We are free to choose any point on the y-axis so long as it meets this condition. They all work, so you might as well pick the simplest, and the simplest one to pick in this case is -1. The simplest case, if you're here, the simplest to pick is 1, 0. If you're on the y-axis positive, the simplest to pick is 0, 1. If you're on the x-axis negative, the simplest to pick is -1, 0. And if you're on the y-axis negative, the simplest to pick is 0, -1. So choose 1, 0, 0, 1, -1, 0, or 0, -1. If you don't like that, you can pick 2, 0, 0, 2, and so on around the circle. It doesn't matter. They all work. You might as well pick the simplest, and I think the simplest is going to be 0, -1. So with that proviso, we now have our values for x and for y. We know x is equal to 0. We know y is equal to -1. And from that, we can compute the value of r. We know the value of r is the square root of x squared plus y squared, which is the square root of -1 squared is 1. We're choosing r to be positive. We choose r to be 1. And so we have r is also equal to 1. Now form the x, y, r definitions, and it's all over but the shouting here. So we're going to take sine of theta. Sine is y over r. -1 over 1. Now, it might not be asking too much. It might not be asking too much. Yeah, you could leave it here. Is it asking too much to say that's -1? I think we're okay asking that. Cosine theta. Cosine theta is x over r. That's 0 over 1, which in this case is 0. Again, you can leave it here if you like. I'm going to go ahead and simplify that. It's probably not asking too much of you to know that 0 divided by 1 is equal to 0. Now, tangent, it gets a little bit dicey. Tangent gets a little bit dicey. Tangent is y over x. Y over x. This is negative 1 over 0. Dividing by 0 is not allowed. Dividing by 0 is not allowed. 0 in the numerator works nicely. Numerator works nicely. 0 in denominator, don't do it. 0 in denominator, don't do it. I know that's a stupid memory device, but I learned it way back when in 19 and it's held me in pretty good stead. 0 in the numerator works nicely. 0 in denominator, don't do it. So this does not exist. All right? Has no value. And then it's nice to have these fractions here. Now don't leave this here because this is not a number. This is one where you actually do. If you left this here, that would not get full credit because this is not a number. You need to know that this does not exist. And then the other values, you can deduce those from these fractions, form the reciprocal. This is 0 over negative 1. 0 in the numerator, it works nicely. Secant theta, this now becomes 1 over 0. 0 in denominator means don't do it. So this does not exist. And cosecant of theta, form the reciprocal here. This is 1 over negative 1, which is, again, still negative 1. So, given that the terminal side of theta is on one of the axes, it could be either x or y, and you would need to be given a specific condition to tell you which piece of the axis. Then you choose the simple point that lies on that side of the axis, x, y, and r. You need to compute the value of r and then substitute the values in. 0 in denominator does not do, or 0 in denominator, do not do that. So 0 in denominator does not exist. Don't leave this answer here. You need to convert this into does not exist. And so for these values, what I am going to ask of you is this. If they are quadrantal, always before I've said you don't need to worry about simplifying. For quadrantal angles, all bets are off. For quadrantal angles, yes, you need to simplify this to negative 1. You need to simplify this to 0. Express this as does not exist, and so on. So for the quadrantal angles, I'm not going to be accepting this version. I will want you to write out this version. The reason is because later on it's better for you. If it didn't matter, I wouldn't care. Later on, it actually is better for you if you get into this habit and don't stay with this bad habit. So write your answers in this form, write your answers in this form, and you'll be good to go if the angle in question is a quadrantal angle.